Hello everyone, this is Miss Grobner, and this is my first ever YouTube video. I'm hoping that it'll help you understand some of our key vocabulary for statistics, and who knows, I might even become YouTube famous. You're going to need the piece of paper that we started last week over statistics. The front of the paper had 6 different charts and graphs. And if you've lost that paper, you need to go onto the Actively Learn website or download the file from the Remind app. Both of these have a copy of our paper there so that you can download that and print it and take your notes rather than having to do it all on notebook paper. The first chart was a histogram, and these are good for showing large data sets. They're most commonly used because they're very helpful in showing data intervals or ranges. You can see how many entry points there were between a specific set of numbers, and that's what they're most commonly used for. The next type of chart we have are box and whisker plots, and these are really great for large sets of data. The one downside to box and whisker plots is that they don't show every single data entry. They show quartiles, and a quartile is called that because each section on a box and whisker represents 25% of the data. So if we look, from this point to this point is 25% of the data. And from here to here is 25%, and another 25%, and the last 25% of the data. We're going to learn more about box and whisker plots later, but for now, you need to know that they show you quartiles, and they can show you, they're really good to see and compare multiple sets of data. The next one is a stem and leaf chart, and this is good when you have several data entries that have similar place value. In a stem and leaf chart, the stem will always be one place value and the leaf will always be another place value. If we look at this chart, we can read it by taking the stem and the leaf and combining them together. So our key down here lets us know that the stem is worth 10 and the leaf is worth 1, making this notation equal 63. So if I were trying to read this, I could read it as the first data entry point being 1, and then the next entry point would also be 1, and then 2, 3, 4, 5, 6, or there is no 6. There are 4 4s, 5, and 8. But the next row would be 10, 10, 10, 11, 11, 13, 17, and 19, and so on. The biggest mistake people make when they're doing stem and leaf plots is that they forget the stem and they just pay attention to the leaves, and that totally messes up our data. So you'll have some practice over creating your own stem and leaf chart today. The next type of graph we had was a pie chart, and these are really good to show percentages and the most common data point that was entered. In this case, they were asking people their favorite type of movie, and we can quickly see that romance, even though it got cut off, was the most common answer, and that drama, which also got cut off, is 5%. These are visually appealing, and it's really easy to see what was the most common answer. So these are really helpful if you're doing non-numerical data and you're asking a question. It's nice to have pie charts. Our next type was line and dot plots, and these show the total values. Unlike box and whisker plots, we can see exactly how many people were questioned, and we can see what the trends were. So if we look here, we're going to learn how to describe these types of data, but we don't want to use these if we have large sets of data that have 50 or more data points. These are good as a quick snapshot when we can see frequency, how often these things occurred, and what was some of the most common. So here, our most common one was 3 as our weight in kilograms. Sometimes you'll be asked to describe the shape of data. And what they mean by that is, what were the trends, or how could I look at the data and make an assumption just by the shape of it? So the data distribution is the way in which the data is spread out or clustered together. The shape of the distribution can reveal a lot of information about the data. There are many different distributions, but the most common ones are symmetrical, which would be this example here. And it's called symmetrical because when we look, if this was our line of symmetry, the data on the left looks very similar to the data on the right. It doesn't have to be a perfect line of symmetry. We're just going to see that it looks very similar to the left and the right. The other way that's most commonly used is skewed left. And in this example, the one on this one is skewed left because there's only a few data points on the left. Most of our data takes place on the right side of our line plot. And our last one is skewed right. And it's called skewed right because there's only a few data points on the right. In this case, it's the opposite of skewed left because most of our data points happen on the left side of our graph. There's a website over here that's really helpful if you want to see what it would look like on other charts, not just line plots. We are also going to learn 2 new vocabulary words today. Well, we're going to learn a lot more, but the next 2 we're going to learn are peak and outlier. And the peak is the highest point on the data. So in this case, our peaks would be here and here because those are the points on the dot plots that have the highest amount of data or the highest frequency in number. An outlier is the point of data that is unlike the rest of the data. It doesn't seem like it belongs, and the way I like to think about it is the outlier is kind of like the outsider. The rest of the data seems pretty close together, but it doesn't seem like it belongs or is apart. So in this example, our outliers would be here and here because the rest of the data is all clustered together in a more closely knit fashion. Also, just to review, do you think this data is skewed left, skewed right, or asymmetrical? And how can we tell? Well, hopefully you answered that this data is going to be skewed right because we have fewer data points on the right, and that this data is skewed left because we have less data points on the left. The next part of our video is going to be some of the main vocabulary that we need and we have to be able to calculate in order to create these graphs and charts. So most of the first few words will be a review, but then the next 3 will be new vocabulary that are really particular for a box and whisker plot. So our first word is mean, and the mean is the average of a set of numbers. So to find the average, we are going to add all of our values together. And today we're going to be using this set of data for all of our vocabulary so you can see how it all works together. So the first thing we need to do is we're going to have to add all these values together, which I did, and they equal 38. Then you're going to divide your sum by the number of values in the set of data. So if we look here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. We can calculate our mean by taking 38, which is our sum, divided by 10 because there were 10 numbers in our data set. And that makes our mean 3.8. A lot of times mean is going to be in a decimal or a fraction, and that's okay. We're just trying to figure out what is most of the data close to? And that's why this is called a measure of center. We're trying to figure out what number is most of the data close to. So if we find the average, that'll help us know that. The next word is the median, and sometimes people will call it Q2. Q2 is relevant to box plots and box and whisker plots. But what you need to know is that the median is the middle number in a set of data. So if we look, the first thing we need to do is put our numbers in order from least to greatest. And this is the step that almost everyone forgets. They just want to come over here and try to find the middle 2 numbers without actually ordering them. But when it says it's the middle of the data, it's the middle of the data when it's in order from least to greatest. So after we've put the numbers in order from least to greatest, we're going to find the middle number by moving from the outside to the inside until there is only one number. In this case, though, we had 10 data points, so we don't have a middle number. We're going to have to take the average of 2 numbers. Here, I have 1, 2, 3, 4, 5 numbers 1, 2, 3, 4, 5 numbers. There isn't one number exactly in the middle, so I'm going to have to add these two together and then divide by 2 because there's two numbers, and I get 3.5. So here, my median is actually going to be 3.5. It's okay if your median is not a number that's in your data set if there's an even number of data points. If there's an odd number of data points, you should just be able to circle the middle number and be done. This is also a measure of center because if we don't have a lot of data points that are random, a mean is the best measure of center. But let's say that we have some outliers. There's a number that doesn't seem like it belongs. The median is going to be a better use of our measure of center. Mode is the most common number in a set of data, and it's possible to have no mode. If none of the numbers repeat, then that means there isn't a most common number, or sometimes the numbers are going to repeat the same amount, so there would be more than one. In this case, we're looking for the number that repeats. We had a couple numbers that repeated. We have 1, 2, 3 threes and 2 4s. A common mistake would be to list that the mode was 3 and 4. That's wrong because there are 3 3s. If there were 2 3s and 2 4s, then you could say that the mode is 3 and 4. But since there are more 3s than 4s, our mode has to be 3. A common mistake here is that with the mode, sometimes people would put 0. We don't ever want to write 0 as the mode if there is no mode, because people could think that 0 is the most common number. So anytime we don't have a mode, we always want to put none rather than 0. Our next vocabulary word is going to be the range. And the range is the difference between the maximum, or our highest value, and the minimum, which is our lowest value in the data set. To find this, we're going to subtract the minimum from the maximum. So I took my list of numbers that I already had, and we can easily tell that the smallest number was 1 and that the highest number was 7, meaning the minimum is 1 and the maximum is 7. So to find our range, all we have to do is take those and subtract. 7 minus 1 is 6, so our range is 6. And this is a measure of variability. Variability is how far apart the numbers are. If you have a very large range, then that could mean that our numbers are very varied. If you have a smaller range, that means that most of our numbers are close together in our data set. Lower quartile, or Q1, is one of the box plot specific vocabulary words that we need to know. And this is the median of the lower half of our data points. So we're going to put the numbers in order from least to greatest, just like we've done, and we're going to find the median. We have to find the original median so that we can split them into halves. Once you've split them into halves, you're going to figure out which one has the lower set of values, and then find its median. And you may have to find an average if it's not an exact middle. So here, when we look, we can tell that this is going to be our lower half of the data. Our median was 3.5. We're going to pretend it's over here. So if we find the median of this lower half, 3 is the middle number. Let's say that we had an even number of data points in the lower half. We'd have to find an average like we did earlier. But here it works out nicely because there are 5 numbers and there's an exact middle, which is 3. Our next word is the upper quartile, and this is really similar to lower quartile, just in the upper half of our data. So this is the median of the upper half of our data, and we still are going to start by putting the numbers in order from least to greatest and find the median. We're going to determine which half is the higher set of values rather than the lower set of values, find its median, and just like before, you will have to find an average if there's not an exact middle. So if our numbers in order from least to greatest, 4, 4, 5, 6, and 7 are going to represent our upper half of our data points. And of those, 5 is in the exact middle, so our upper quartile is 5. Our last vocabulary word is the interquartile range. An interquartile should help you realize that you're figuring out what's in between the quartiles, what's in between the lower and upper quartile. So this is the range between the upper and lower quartiles. And just like before, when we see range, we know we're going to have to subtract. So we subtract our lower quartile from our upper quartile. And this is also going to be a measure of variability. Anytime you see range, it's going to let you know how far apart your data is. So here, when we were looking earlier, we had 3.5 as our middle, our median, and we split it into a lower half and an upper half. Our lower quartile is 3 and our upper quartile is 5. So we should be able to find our interquartile range by taking those values and subtracting. 5 minus 3 is 2, so our interquartile range is 2. And if you look at a box and whisker plot, this is why that vocabulary is really important. We have to be able to calculate all of these values in order to make this box and whisker plot. We have to know what is our minimum, what's our lower quartile, what's our median, our upper quartile, and what's our max. And we're going to actually take some time in this video to learn how to create one of these. But first, we're going to start with something simple, and that's just to create a dot plot. So I took our same data that we've been using in the whole video, and we're going to create a dot plot. With this, you need to figure out what numbers are represented. Since I could tell by looking at my data that the smallest number is 1 and the highest number is 7, I first create a number line that has all of those numbers included in it. So sometimes your dot plot might not have every number represented with a dot, but that's okay. You just need to make sure that all the numbers that are represented are present on your number line. Then we just put dots for every number we see. So the first number I saw was 3, I put a dot at 3. And then 4, and then 6, and then 2, 3, 5, 4, 1, 7, and 3. When we look here, we can tell that we have all of our data placed, and we can check that by counting our number of dots. We knew there were 10 dots from finding our mean, so let's count again to make sure that we're correct. We haven't missed any numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know we have all of our data points entered. Is this data skewed left, skewed right, or symmetrical? And how can we tell? This data is what I would call symmetrical because we have our peak near the middle of our data, and there are some numbers over here and some numbers over here. I would say it's closer to symmetrical, but some might argue that it could still be skewed right because there are fewer numbers. But when you look, there's still 5 over here. There's 1, 2, 3, 4, 5, 6, and there are 1, 2, 3, 4, 5 numbers here, and 1, 2, 3, 4, 5 numbers here. So our median was 3.5, and it's even on both sides, and it looks even with our dots. So I would call this a symmetrical data distribution. Now we're going to take the same data that we've been looking at, but we're going to need our information from earlier. We knew that our median was 3.5, our minimum was 1, and our maximum, we'll get to those in just a second. So these are the 5 different things that you need to make a box and whisker plot. Our median was 3.5, so you draw a line where 3.5 would be on your number line. Notice I'm writing above the number line. We don't ever want to put our box and whisker plot directly on our number line. We're always going to draw it above it. So our median was 3.5, so I'm going to draw a line at 3.5. Our minimum was 1, so then I'm going to draw a line at 1. Our maximum is 7, so I draw a line at 7. Our upper quartile is 5, so I draw a line at 5. And our lower quartile was 3, so I'm going to put a line at 3. Now that we have all of our lines represented on our box and whisker plot, we have to create a box using our median, lower quartile, and upper quartile, and the whiskers, which will connect our box to our minimum and our maximum. So if I create this box, the next thing I need to do is create my whiskers. And we should note that the box is always going to be the middle 3 and the whiskers are going to be on the outside, just like whiskers would happen normally. So today, what I would like for you to work on is there's a half piece of paper on box and whisker plots that has 3 problems. There's a piece of paper that said homework practice that has a front and a back where you're going to get to practice doing some dot plots, stem and leaf plots, and box plots. And there was one page over pie charts, and the question was talking about what was the most common type of nut. So you're going to need to do those pages today while you're at home. If you have any questions or you're not sure, then you can always email me or message me on the Remind app, and I'd love to help you. Thanks for watching, and good luck.